If a is any real number and n is non-zero positive integer, then a power n is equal to a into a towards n times. If a is any non-zero integer, then a power 0 is always equal to 1. So anything to the power 0 is always considered as 1. A power m plus n can be written as a power m into a power n. Similarly, a power m minus n can be written as a power m by a power n. Hello everyone, a warm welcome to one and all. This is Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are learning about the theory of indices. Before that, let us see the weightage of this chapter for this academic year. From the chapter Theory of Indices, you can expect one multiple choice question and one long answers and a 3-mark question. So overall, in the question paper, you will be having 2 questions from this chapter, overall 4 marks. So theory of indices is nothing but which is a basic concept which you have already learned about the law of exponents. So here also we revise all the laws of exponents and we'll take few problems related to it. Before that, let us see the topics for this today's discussion, that is the laws of indices. Now, meaning of a power n. If a is any real number and n is non-zero positive integer, then a power n is equal to a into a towards n times. So we know that instead of writing a into a, we usually write a square. Instead of writing a into a, we'll write a cube. So we call a as the base and 3 as the index or the power or the exponent. So similarly, a number in the form of a power n is called an exponent or the indices form. So here a is called the base of the exponent and n is called the power or the exponent. Now this is an exponential number. So always remember a can take any value. It may be positive, negative or 0, but n is always the positive integer. Laws of indices. The very first law of indices says if a is any non-zero real number and mn are 2 positive integers, then a power m into a power n is equal to a power m plus n. For example, 2 cube into 2 power 5 can be written in the form of 2 to the power 3 plus 5, which is equal to 2 power 8. So the value of 2 cube into 2 power 5 is same as 2 power 8. Next, if a is any real number, m and n are 2 positive integer, then a power m by a power n is equal to a power m minus n if m is greater than n and n minus m if m is less than n. For example, if we have 2 cube by 2 square here, then we can write it as 2 to the power 3 minus 2. Remember, this can be written only when you have the same base with different exponents. So this is equal to 2 to the power 1. So here m is greater than n. Suppose if n is greater than m, then we can write this in this form, a power n minus m. The third law says if a is any non-zero real number, m and n are 2 positive integers, then a power m into whole power n is equal to a power n. When the same base have 2 different powers. For instance, you can consider we have 3 square whole to the power 1 by 2, then we can multiply the exponents. So therefore, this becomes 3 into 2, 1 by 2, which is equal to 3 power 1, which is equal to 3. So based on the third law, we have few important concept. If a is any non-zero integer, then a power 0 is always equal to 1. So anything to the power 0 is always considered as 1. If a is non-zero integer and m is positive integer, then a power minus m can be written as 1 divided by a power m. So I told you n should be always non-zero positive integer. In such case, if you have minus m here, then for instance, if we have a power minus 2, then we can write this as 1 divided by a square. So we can write the power in terms of the denominator, because n should always take the value of non-zero positive integer. Next, If A is non-zero integers, P and Q are positive integers where Q is not equal to 0, then Qth root of A to the power P can be written as A to the power P by Q. So this is an example for an irrational surd here. So suppose we have here cube root of 4. So cube root of 4 is nothing but 4 to the power 1 by 3. So similarly, if we have one more power, like for example, cube root of 7 square, then this is nothing but 7 square whole to the power 1 by 3. Using the third law, we can multiply the powers. So this becomes 7 to the power 2 by 3. Now let us take few problems. Simplify 9 divided by 4 whole to the power minus 3 by 2. We know that when we have a negative power, we can make the power by writing the base in denominator. So here we have 9 by 4 whole to the power minus 3 by 2, which can be written as 4 by 9 whole to the power 3 by 2. Again using the third law, we know that a whole power m can be written as a to the power mn. That means mn can be separated as a power m whole power n. We can also write this in the form of a power n whole power m if required. So now here I'll take 4 by 9 whole to the power half whole to the power 3. 1 by 2 is nothing but the square root. So square root of 4 is 2 and square root of 9 is 3. And outside here we have whole cube. So the value is equal to 2 cube 8 divided by 3 cube 27. So when you have same power for two different elements, we need to take the individual power for both the numbers. Next we have simplify a to the power m plus n, a to the power 2m minus n divided by a to the power m minus n. So remember here we have two numbers on the numerator and one number in the denominator. So using the first law and second law, a power m into a power n can be written as a power m plus n, and a power m by a power n can be written as a power m minus n. So using that rule, since the base is common here, we can write a to the power m plus n plus 2m minus n, and since this is in the denominator, I should take negative of the power, so minus of m minus n. Now we have a to the power m plus 2m, 3m. N and minus n get cancelled. Next we are left with minus m, minus into minus, plus n. So the value is a to the power 2m plus n. Next question. Simplify cube root of x square whole cube whole to the power 1 by 2. So using the third law, a to the power m whole power n can be written as a to the power m into n. Now here we have cube root of x square whole to the power 3 whole to the power 1 by 2. So this can be written as 3 into 1 by 2. So which becomes cube root of whole square to the power 3 by 2. Again cube root can be written as x square whole to the power 1 by 3. In index form, cube root is nothing but 1 by 3 whole to the power 3 by 2. Now again we have two different powers. If we multiply them, cube get cancels here or 3 get cancels. Now we are left with here x square whole to the power 1 by 2. Now again we have m and n form, so which can be written as m into n. If we multiply them, 2 and 2 get cancelled, so we are left with x. So using the third law of indices, the value of this is equal to x. Next, simplify 2 to the power n plus 1 plus 2 to the power n minus 1 divided by 2 to the power n plus 2 to the power n plus 2. Now using the laws of exponents, a power m plus n can be written as a power m into a power n. Similarly, a power m minus n can be written as a power m by a power n. So here 2 power n plus 1 can be written as 2 power n into 2 power 1, 2 power n into 2 power minus 1 whole divided by 2 power n plus 2 power n into 2 square. Here in both numerator and denominator, 2 power n is the common term. So we are left with 2 here. 2 to the power minus 1. That means a to the power minus m can be written as 1 by a power m. So here it becomes 1 divided by 2 power 1, which is 2 itself, whole divided by 2 power n, 1 plus 2 square. We can cancel 2 power n. 2 plus 1 by 2 is 2 2s are 4, 4 plus 1 5. So 5 by 2 whole divided by 1 plus 2 square is 5. So the value is 5 divided by 2 into 5. 5 get cancels. So the value is equal to 1 by 2. Next question. Simplify 2 to the power 7b minus 2a, 8 to the power 2a minus b, whole divided by 16 to the power a plus b. So clearly, we do not have the common base here to apply the law of indices. So I'll make 8 and 16 in terms of powers of 2. So let us write 2 to the power 7b minus 2a as it is. 8 can be written as 2 cube. And the power is here 2a minus b, whole divided by 16 can be written as 2 to the power 4 whole power a plus b. Now we have 2 to the power 7b minus 2a into 2 to the power 3 2s are 6a minus 3b whole divided by 2 to the power 4a plus 4b, multiplying the powers. Now let us apply the first law and the second law. So then here with the common base we'll get 2 power 7b minus 2a. Now since this is in the product form, the powers is added. So here we get 6a minus 3b, and here it is in the quotient form. So m by n means it has to be written as minus n. So this will be minus 4a minus 4b. So resolving this, 7b minus 3b minus 4b get cancels because minus 4b plus 4b cancels. Minus 2a plus 6a is 4a. 4a minus 4a is 0. So we are left with 2 power 0. We know that anything to the power 0, for any base, if the power is 0, the value is always 1. Hence, the value of this problem is 1. Next, simplify 2 to the power 2 power 0, 2 power 0 whole cube, whole divided by 2 cube whole square, 2 square to the power 0. So now 2 to the power 0 is nothing but 1 plus we have 2 different power here. So 0 into 3 is 0. So 2 power 0 whole divided by 2 different power, 3 2s are 6. So 2 power 6 plus 2 zeros are 0, 2 power 0. So here we have 2 plus anything to the power 0 takes the value 1. So 2 power 6 is nothing but 64 plus 1. So we have 3 divided by 65. Next question. If a power x is equal to b, b power y is equal to c, and c power z is equal to a, then show that x, y, z is equal to 1. So using the concept of indices, we need to show that x, y, z is equal to 1. Now consider a power x is equal to b as equation 1. Next, b power y is equal to c as equation 2. C power z is equal to a as equation 3. Now c is nothing but b power y from equation 2. So instead of c, I'll substitute b power y and whole power z is equal to a. So this is using equation 2. Now since the same base have 2 different powers, we have p by z is equal to a. Now again using equation 1, instead of b, I can write a power x. So a power x whole to the power yz is equal to a. So this is using equation 1. Now here multiply the powers. We are left with a to the power x yz is equal to, here it is nothing but a to the power 1. Now base are equal. Since bases are same, the powers can be equated. So therefore we can write x, y, z is equal to 1. Next question. If 45 to the power 1 by x is equal to 3 to the power 1 by y is equal to 5 to the power 1 by z, prove that x is equal to 2y plus z. Now, let me consider 45 to the power 1 by x is equal to some k. And similarly, 3 to the power 1 by y is equal to some k. And 5 to the power 1 by z is equal to some k. Since all of them are equal, they have to be equal with the same quantity. So this implies, so if you convert this to the exponent, then we will get 45 is equal to k to the power x. So now here we will get 3 is equal to k to the power y, and here we get 5 is equal to k to the power z. Now consider the first equation here. So this is the second, this is the third. Now let me consider here 45 is equal to k to the power x. Now 45 can be written as 9 into 5 is equal to k to the power x. 9 can be written as 3 square into. From equation 3, 5 is nothing but k power z. So I'll write here k power z is equal to k power x. Again from equation 2, 3 is nothing but k power y. So if I substitute 3 as k power y here, whole square into k power z is equal to k power x. So when you multiply here, we will get k to the power 2y into k to the power z is equal to k to the power x. So here since bases are equal, I can write k to the power 2y plus z is equal to k to the power x. Using the law of exponents, a power m into a power n can be written as a power m plus n. So now here we have the equality of two exponents. Since the base are equals, the powers can be equated. So therefore we can conclude x is equal to 2y plus z. Next, prove that 1 divided by 1 plus x to the power p minus q plus 1 divided by 1 plus x to the power q minus p is equal to 1. Now consider the left hand side. So we have 1 divided by 1 plus x to the power p minus q plus 1 divided by 1 plus x to the power q minus p. We know that a power m minus n can be written as a power m by a power n. So using this concept, I can write the denominator here x to the power p by x to the power q. Similarly, 1 divided by 1 plus x to the power q by x to the power p. By taking the fractions addition here, we get 1 divided by x to the power q plus x to the power p whole divided by x to the power q plus 1 divided by x to the power p plus x to the power q whole divided by x to the power p. We know that we can write x to the power q in the numerator and p here to the numerator. Now we get x to the power q divided by x to the power p plus x to the power q plus x to the power p divided by x to the power p plus x to the power q. So we get x to the power q plus x to the power p whole divided by x to the power p plus x to the power q. So irrespective of the order, the numbers are one and the same. So therefore, this get cancels and the value is equal to 1. That is the right hand side. Hence, prove. So in the next session, we'll take few more problems related to the laws of indices. Until then, keep watching, keep learning and keep exploring. Thank you.